Extracting market segments is an exploratory exercise. While exploring, it is a good idea to use a number of different extraction methods. Using model-based methods in addition to distance-based methods is useful because model-based methods extract market segments in a very different way. Distance-based clustering methods use similarities or distances to assess which consumers belong to the same market segments. Model-based methods don't. When we use model-based methods, we assume that the true market segmentation solution, which we don't know yet, has two general properties. 1. Each market segment has a certain size. 2. If a consumer belongs to market segment A, that consumer will have characteristics which are specific to members of market segment A. We believe that those two general properties are true, but we do not know in advance the exact nature of those properties, the sizes of these segments, and the values of the segment-specific characteristics. What model-based methods do is to use the empirical data to help us find the values for segment sizes and segment-specific characteristics by selecting those which best possibly reflect this data. It's a bit like taking a general structure and then using the consumer data to fine-tune it. The model-based methods we use here are called finite mixture models because the number of market segments is finite and the overall model is a mixture of segment-specific models. Our finite mixture model consists of the two properties we just discussed. We can write down those properties in a more formal way. Property 1 is expressed as follows, which tells us that segment membership Z of a consumer is determined by the multinomial distribution with segment sizes pi. Property 2 is expressed as follows. The segment-specific characteristics are captured by a vector theta, which contains one value for each segment-specific characteristic. The x's are additional pieces of information we may or may not have about each consumer. The function f tells us how likely we are to observe certain values for y in the empirical data if a person is a member of this segment. The overall finite mixture model we need to estimate looks like this. It tells us we need to estimate across all segments h, which range from 1 to k, the segment sizes pi, and the segment-specific characteristics theta. Segment sizes pi have to be larger than 0 and sum up to 1. The values that need to be estimated are called parameters. We have a number of options how to estimate these parameters. A common approach is to use maximum likelihood combined with an expectation maximization algorithm, also called EM algorithm. An alternative is to use Bayesian estimation. Whichever approach we choose, once we have estimated the finite mixture model, we have determined values for segment sizes pi and segment-specific characteristics theta. We can assign each consumer in our empirical dataset to their market segment using the following approach. What happens here is that we calculate the probability of each consumer being a member of market segment H. We then use the probabilities for all market segments to assign each consumer to the segment with the highest probability. The finite mixture model we estimated was for one particular number of market segments, but we do not know that this is the true number of segments or the best number of market segments to choose. To select a good number of market segments to extract, we can calculate finite mixture models for a range of numbers of segments and compare them. There are three commonly used comparison criteria. The Acker-Icke information criterion, or AIC, the Bayesian information criterion, or BIC, and the integrated completed likelihood, or ICL. In all those formulas, L is the likelihood. P represents the number of estimated parameters in a model, and N is the sample size of the consumer data. The idea underlying all of those criteria is to measure how well the model fits the data while penalizing it for model complexity. In most cases, the AIC penalizes less than the BIC, and the ICL also considers how well separated the market segments are. As a consequence, it tends to recommend smaller numbers of market segments. At first glance, finite mixture models may appear unnecessarily complicated. The advantage of using such models is that they can capture very complex segment characteristics and can be extended in many different ways. If you do further reading, keep in mind that the finite mixture model literature uses the following terminology: components for what we call market segments, prior probability for what we call segment size, and posterior component probability for what we call the probability of each consumer to be a member of each segment.